So I bought this cheap electronic throttle body off of eBay. I have no idea how well it works, but it seems to be good enough for Corvettes, so I think it'll be good enough for me. I'll have to come up with a strategy for controlling this, and that's in a future video. For now, the immediate task is to adapt this throttle body to the intake of the 460, and since I'm using the stock intake runner, I'm going to have to custom build this thing. Step 2 was rendering the throttle body adapters in CAD and making sure that I had accounted for all the variability in the parts themselves. Since I'm using an older Ford engine and I'm attaching a newer GM throttle body on top of it, I need an adapter. The adapter is going to need 4 basic parts, these 2 halves of the actual adapter cone, and then it's going to need a top and a bottom flange in order to mount from the engine to the throttle body. In the previous videos, I 3D printed the templates that I'm going to use to route around the base flange, and that base flange is going to be the part that mounts from the original engine intake manifold and then connects to the adapter cone, and then sitting on top of that is going to be another flange that adapts to the throttle body. In the previous video, I made significant progress. I got the bottom flange completely welded together, and then I shaped it using some files and some sandpaper. Then I attempted the routing procedure. So, there's a problem. I was trying to use a wood-cut flush trimming router bit. It's a 1/4 inch shank. And it's only got these 2 flutes, 180 degrees from each other. It's carbide, so it can cut aluminum fairly easily. It can cut wood even better. But I think the axial loads got a little too high for it. There's only 2 cutting surfaces on there. So for each revolution, each one of those is taking a pretty big chip, and I think it got caught on this particular cutter, and it just snapped that carbide right off. You can see it in the video, I think, in the very beginning of the video when I was running this the first time. So in order to prevent that from happening again, I got a spiral flute cutter. And this cutter reduces the axial load by spreading it around 360 degrees around the shaft. So there are 2 opposed cutting heads. It's a double helix. But for every revolution, it's going to push the chips up in a smooth manner instead of taking one big chunk out of it every half revolution. So I think that's going to reduce the axial loads. I think that might give me a cleaner finish. I think it's going to make for a lot more smoother cutting. At least that's the goal anyway. So we'll try it out. Future me here from the end of the video. Cutting this was pretty sketchy. I really don't like having my fingers that close to a spinning blade. If I'm going to do this again, and I probably will, I would definitely create some kind of jig or some kind of sled just in order to keep my hands a little further away from that spinning device. I also had some problem clearing the chips, so it might be worth my time to invest in maybe an adapter for this vacuum hose. You want to take the big can out?
No.
Okay, I'll take care of that.
It's on my install.
Excuse me, ma'am. This requires a high level of concentration and precision.
I didn't realize we were recording.
Oh yeah, now you're motivated?
I'm
Yep.
just making sure the angles are right. Keeping me fully pregnant.
Now it's time to make the anvil that I'm going to use to shape the 2 sides of the adapter cone. So here we are, making my best approximation of that three-dimensional shape out of wood. I'm going to use this as sort of a template to mold those aluminum flat sheets into this compound curve here. But what I need to do is smooth all this out and get a little more accuracy in the final part. I don't think that's really necessary, but I'm a masochist, so we're going to keep going. And I'm going to put my Flange degree to full use by engineering a proper sanding plate, belt sander, universal part maker. So this probably isn't going to work, but let's find out. Well, that worked surprisingly well. Fresh 40 grit from the Hobo Cargo store. Made a little bit of mistake here. This edge isn't quite as round as it should be, but 3 out of 4 ain't bad. Looks like I've got the proper offset. If you look really closely at the throttle body adapter portion, the front edge, I'm just going to call it the front edge, is a little thicker than the rear, so that offsets it just a little bit. So as you got the throttle body here, you can see that, well, one-handed, this lip right here is thicker than this lip, so it's not really the front, it's the side in this case. But I need to make sure that the front lip that's larger is on this side when I go to mount it to the flange down here, so that this stays in the correct orientation. And speaking of correct, I still haven't decided whether I want it this way or this way, but I don't think that makes a whole lot of sense, and there isn't a whole lot of room that way. I think that's going to be hitting fuel rails and valve covers, so I guess you and I just decided that that's the way it's going to go. Okay, so this is a trick I picked up from another YouTube channel called 6061. That's 6061. He's a very well accomplished aluminum fabricator. Does a lot of really helpful trainings. He's got seminars and courses on his website. And you know, I haven't taken any of them. Probably should. He'd probably teach me a whole bunch and help me not screw up a whole lot. But he did a great little quick video about how to make this exact shape. And I pretty much followed his method, with the exception of this part right here. And I don't know if this is going to work. You know, high likelihood it won't. But I think this might improve on it a little bit. What he did, he took a piece of blank, like notebook paper or printer paper or something, and then folded it on this curve and ran it over with a pencil, then pulled it off and cut it out. And I saw that it definitely worked. But I thought I might be able to improve on the accuracy of this just a little bit if I were to throw some tape on here and then use the old masking trick that I learned from working on the block there, of taking a file and running it along the sharp edge. Yeah, that seems to be working okay. And it'll give you a fairly clean little cut, and it'll match the contours really well. So I'm gonna try that. And then the goal here is to unfold this after it's all cut out and then use it as a template to cut out the aluminum that I have to wrap into this shape. And the reason I'm going through all this trouble of making this template is that this is a really weird shape. You could probably mathematically figure out how to cut this out from a flat piece. You know, I literally drew it up in CAD first and then did a projection of the shape, and I could print that out and I could, you know, make sure it conforms and all that stuff. Or I could just skip to the end, throw some tape on here, and let the shapes be what they are, and it'll be more accurate anyways. So that's the whole point. So I'm not going to make you sit here and watch me tape this up and mark it, but you can watch it and fast forward. So enjoy. Okay. So now we've got our shapes cut out here. Topology has always been an interesting subject to me, but I've never studied it formally. I'm really only just now kind of getting into 3D animation, and topology plays a big part there. Believe it or not. And at least the modeling part does. But I do know that this shape is definitely complicated. And having a template like this to cut out is going to make fitting way easier. I think that tape is a good idea because it can just stick to this now. Okay, I would call that a success. We'll see how the metal turns out. Oh, there it is. So we can mark this out. I am not going to bother being too precise. This is going to have to get shaped and cut out with a bandsaw. But the whole point is just to get it close enough so that it doesn't require a ton of fiddling. I suppose I could use some spray paint. That might be a little better. Just psst, psst. Or Derek says, the old yes. Rebuilt. Brand new. I just lost the receipts. Why purple? Oh, I don't know. It's just what I had in the peanut butter jar. That's where I keep all my pens. Actually, I think it's a pickle jar. Doesn't matter. Probably not even going to include this on the final edit, because nobody wants to hear me ramble about pickle jars. Okie doke. I think that's close enough. Let's go take it to the bandsaw. Life is good. So, I've got here what I affectionately call my bad idea fairy. Why? Well, whenever this bad boy comes out, it's always a bad idea. Almost always. I think for some plumbing jobs it's actually appropriate. But most of the time, this is a bad idea. Kind of like now. So my idea here is these, I don't know if you can see that or if it's going to come through on the video. These are pretty hefty. They have to be. And they're very difficult to bend. And I don't want to be wailing on this thing with my fingers really close to it, which is going to be what's required to bend this into shape on that wooden form. So I'm going to attempt something I've never done before, which is annealing aluminum. The theory goes, if you get this hot enough, that the molecular structure or something will soften. Science, basically, is what happens. And then this becomes easier to form. Let's try it out. I should also add, I'm not going to form this while it's hot, if that wasn't clear. I mean, I'd burn myself. So I'm going to heat it up and then let it cool down. And it should, at least in theory, be a little more pliable. Okay. Alright, so I have no idea what's hot enough. I'm sure there's going to be some metallurgist eventually going to watch this video, probably in 30 years, and think what an idiot I am. But I'm just going to go until I think it's enough and then push it, 20% more. So it's just right. Let's see if that worked. I'm going to let it cool down. All right, according to science, annealing aluminum happens at about 500 degrees. And another thing, according to science, is that Sharpie marker burns off at about 500 degrees. So in theory, I could use some Sharpie marker as it burns off to gauge whether I'm getting the metal hot enough to actually anneal it. So I'm going to stick this in the vise. This is the second piece, by the way. Stick that in the vise, and then you guys keep an eye on that at home. Tell me when the Sharpie marker starts to disappear on that. All right. All right. Don't get distracted now. I think what we're shooting for is all these guys disappearing. I'll try and heat it up evenly from the back. Just keep an eye. Let me know when I need to stop, is what I'm asking. Anything happening yet? Well, check it out. After reviewing the footage, it indeed did disappear. I still see little faint indications, but that looks like that man it worked. I have no idea if that reached the right temperature, but we burned off some Sharpie. I'll call that a win. So here's what I got. After definitely taking a methodical and organized, evolved approach, I definitely wasn't bashing on this with a variety of hammers in my feet like a caveman. What I found is I can just stick this in the vise, give her a few love taps. The next step in this process, I think we're going to take the original hardware, even though it looks kind of cheesy. We're going to have to drill and tap this. The throttle body sits on top of it, and it's just a through hole, and these bolts need to sink into something. So I guess they're called cap screws. Yeah, they're cap screws. So I think what I need to do first is figure out what the thread size is here. Let's see here. I think this is M6. Yeah. Most likely metric since I bought it from eBay. No, it looks like M6 is okay. Oh, no. Getting a little tight. Try an M7. That goes through no problem. It's a little wobbly. So if I use the old trusty calipers, 5.85 means this should be an M6. Go hunting for a disorganized tap in here. None of these are put in the right spot. And 10. I'll tell you, it sure is nice working with aluminum sometimes. Working with stainless or with mild steel gets a little tricky, especially if you don't have the right equipment, and I clearly don't. Okay, those holes look pretty good, pretty well lined up. I think it's safe to go ahead and move on to the next stage. I think that's going to work. Okay. Let's see how this all lines up. Okay, leave that a little loose. Looks like the fit is pretty good. I think I'm realizing future me is going to have to deal with access to this right here. I might have to change out the hardware too, some hex heads or something, because I think what I plan to do is put a V-band clamp adapter onto this. I'll have to weld a V-band half over here, and that is not going to give me room to get the Allen key down here unless I want to get real silly with the angled stuff. And I don't feel like doing that, but there's also no room between here. So I think we just discovered another engineering hurdle we're gonna have to get past. But that's for future me. And you know how I feel about that guy.
Bruh.
All right, well, I've successfully mounted this to the bottom, to the top flange. Need to make sure that nothing's gonna hit here. It looks totally free, totally fine. The alignment's okay. There's a lip here. Gonna have to adjust this a little bit. I think that circle is just ever so slightly off. Say it's probably about a 1/16 of an inch or so. Not a huge deal. I can always put a little bevel or a chamfer on this side to reduce any kind of turbulence that this will hit. So that works out pretty good. On to the next big step. And there we go. Got the base plate, which has been lined up and trued with the intake. We've got the 2 adapter angles, the main body of it. Those will get spot welded together, and then I'll probably end up flattening this out a little bit with the file. And then we've got the top plate adapter, which goes to the actual throttle body itself. I guess the next step is to clean everything up and then start tack welding this together. Not too shabby. After a little bit of work with a file and some sandpaper, got this kind of flat. At least it fits on here okay. And I think more importantly, this lines up pretty well. So the next step is attach all 3 of these together. Since I've got everything prepped. Do I have everything prepped? Pretty sure I do. Let's go to commercial. On to prep. This has a bunch of super glue on it left over. So what is that? I'm not really sure how to do that, but I have an idea. Computer, how do you remove super glue from aluminum?
From glued.com, a solution of alcohol or acetone will remove super glue from most surfaces.
All right. Well, I have acetone. So one more final cleaning and then we'll tack this in place. Just making sure everything's as even as possible back here. I'm also going to look at centered here, centered-ish here. That looks pretty good. Let's see if I can see anything from this camera angle. With my helmet on. I'm gonna need to be open here. Touchdown! Darn it. Okay. Well, there she is, folks. Don't look too close. If you start checking out those welds, and I'm showing you the pretty side, it's going to be embarrassing for us both. Just kidding. It's actually just going to be embarrassing for me. It was a fight. My big issue was I had large gaps in between the pieces here. I thought I could get away with it better than that. But here's the thing. If you got a gap behind that that's too big, air is going to come back in and contaminate your weld as you're welding. I didn't realize that. I had no idea that that was a thing. I'm still a brand new aluminum welder. I thought that the gas would push through and there'd be a nice envelope, but actually what ends up happening is that as you lay down your beads, some of the molten aluminum will go around to the backside and it'll pick up, it'll oxidize, and that's called contamination. It'll float back on the puddle and it'll come back to the front, and it makes this horrendous mess. It just changes the whole arc, starts jumping around, it gets real bright and fizzy, and you can't control the puddle, and you start wandering and meandering. And the only way that I found to get through that was to push through and just goop the metal on here until it sealed off the hole. And then things started behaving a little bit better. And as I went around, I ended up hitting another hole here. But then I pushed through and things got better. This is what I think my level of skill should be right here. If I had a nice tight seam like I did across this gap here. So I think that's the key. Now, I believe those welds will hold at least good enough, to be a hobby project, right? I wouldn't sell this to anybody, good Lord. But I think it's good enough for now. And if I wanted to make another one, I could. I've got all the pieces I need and all the tools. So that's an option. But for now, I think that what I'm going to do is move on. I want to move on to electronic control of the throttle body itself. And that requires a little bit of programming and some fancy pants electronics and some open source stuff. And that's going to make a fun video. But for this one, I appreciate you guys coming along. This has been a long journey, especially for me. It took me about 5 weeks to get this out. various other things were happening going on. But the end result is I've got this fully fabricated and marginally functional part.